May 16th, 2026. These are the most important stories since yesterday. In AI, ChatGPT cracked a number theory puzzle called Erdős Problem 1196 in roughly 80 minutes, settling a question a Stanford mathematician had worked on for 7 years. In science, researchers transplanted spinach-derived chloroplasts into living mouse retinas, and the organelles kept producing cellular energy inside mammalian tissue for several days, per a new paper in Cell. In medicine, a Nature cell biology study found that cancer cells exploit vitamin B2 to evade ferroptosis, and that a bacterial analog called Roseoflavin triggered cell death across multiple tumor types. In tech, a NASA-led team tested a radiation-hardened neuromorphic processor in orbit and found it runs inference roughly 500 times faster than the spaceflight computers currently flying. In medicine, a phase 3 trial published in the New England Journal of Medicine found that the oral antiviral Ensitrelvir cut symptomatic COVID in exposed household contacts to 2.9% compared to about 9% on a placebo. In labor, Detroit's 3 legacy automakers have eliminated more than 20,000 U.S. salaried jobs since 2022, and Ford's CEO publicly stated that AI will replace roughly half the company's white-collar workforce. In governance, a federal judge declined final approval of Anthropic's $1.5 billion author copyright settlement after objectors challenged a proposed $320 million legal fee that would leave individual authors about $3,000 per book. Deeper dives on all of this are in today's Century Report, and many are discussed further in today's podcast. Links to both are in the description. Or if you're already here on the podcast, let's get into it now. Let's start with Mike Selke, the Stanford mathematician. He had been chipping away at an open problem from Paul Erdős, known on the registry as Problem 1196, for 7 years. Intermittently, notebooks, partial results, candidate constructions that did not quite close. Mathematicians live with problems like that for decades. It's the texture of their work. He fed the problem to ChatGPT with a code interpreter attached. Roughly 80 minutes later, the model handed him a proof. He traced through the steps, and it checked out. He wrote it up, submitted it, and credited the model as a contributor to the search process. 7 years of intermittent work and 80 minutes of conversation solved. So slow down. What did the model actually do? Because this is the part that most coverage will kind of smudge over. The Erdős problems are a living registry of unresolved questions. 1196 was unsolvable at the moment the conversation with ChatGPT started. The model worked the problem from scratch through candidate constructions, small computational checks, refinements, and assembled a structural argument Selke had not been able to build on his own. He still had to recognize the proof was valid, of course. He still had to situate it in the literature. He still had to write it for human readers. But what changed is that the first half of mathematical discovery, the years-long conjecture and test loop, folded into a session. For most of mathematics history, the rate at which new proofs appear has been bounded by how many minds can hold a problem in attention for a decade at a stretch, sometimes longer. That bound is what made mathematical research a very slow discipline. If a frontier model can compress 7 years of intermittent work into 2 hours on an open problem, then the bound starts to move. The Erdős list has hundreds of problems in the same register. The capability that solved 1196 generalizes beyond 1196. So what follows is a generation of mathematicians who arrive at problems with collaborators that hold the full search space in working memory and produce candidate proofs at conversational speed. If you've ever wondered what the next decade of basic science actually looks like, the foundational work, the open conjectures, the thing that mathematicians have been trying to prove since before you were born, what just shifted is the clock those problems run on. A reasonable read of this is that the registry of open Erdős problems gets meaningfully shorter over the next year or two, and the part of math that was historically about solitary endurance gets reshaped around something that looks more like a simple conversation. The conjecture and test loop that consumed years is now something you can finish before lunch. All right, let's shift away here. Different domain entirely. A team publishing in Cell took chloroplasts, that's the green organelles that do photosynthesis inside plant cells, harvested them from spinach leaves, and transplanted them into photoreceptor cells of mice inside the mammalian retina, exposed to light. The chloroplast kept working. They produced ATP and NADPH, that's the energy and reducing power currencies that cells run on, for several days before the host finally broke them down. So the mice tolerated it. The retinas kept responding to the light. Now, I had to read that a few times to really understand it. Chloroplasts are descended from a cyanobacteria that moved into eukaryotic cells more than 1 billion years ago and became permanent residents in both plants and algae. Mammalian cells have never housed them. The textbook assumption, and this was solid textbook material, was that a plant organelle inside an animal cell would be rejected, degraded, or simply non-functional. The host's surveillance would catch it. The import pathways would fail. The redox chemistry would clash. The Cell paper reports, though, that none of those failure modes dominated on the timescale measured. The chloroplasts photosynthesized inside a mouse eye. The therapeutic frame that the authors raise is retinal dystrophy, which is a class of inherited blindness where photoreceptor cells degenerate because they cannot meet their energy demand. Photoreceptors are among the most metabolically expensive cells in the mammalian body. A photosynthetic auxiliary inside a cell, drawing on the light that the eye is already collecting, is a structural answer to that constraint. Now, this is big, this is almost fringe, so I want to be really careful here. The demonstration is in mice. The chloroplasts only last days, no longer than that right now. What the paper does, though, is move that date when treating a category of inherited blindness becomes possible. It doesn't make it possible tomorrow, but soon. The deployment work, such as sustained function, primate models, safety review, regulatory pathway, that's usually years. What the paper establishes, though, is that the boundary held to be uncrossable is not. The engineering question has to be shifted now from is this possible to how long can it be sustained? And that is a very different question. The deeper signal is what the result implies about the categories themselves. The plant-animal divide has organized biology since Aristotle. This Cell paper is one report in a growing set where cross-kingdom transfers are producing function. The boundary is not where the textbooks drew it. A graft can be rejected by the tissue that was already there, or it can also take root and feed cells that could never have produced on their own what it now delivers. All right, switching tracks here. GM, Ford, and Stellantis have together cut more than 20,000 U.S. salaried positions since 2022. GM is about 11,000 of those, Ford about 5,300, and Stellantis about 4,000. The cuts are concentrated in the white-collar functions legacy manufacturers historically protected: engineering management, finance, procurement, marketing, corporate planning. Ford's CEO has said publicly that he expects AI systems to absorb the work of roughly half the company's remaining salaried workforce. The cuts are structural. Detroit's hourly headcount has been stable or rising at several plants as EV production lines ramp, and the same structure showed up at Cloudflare a week ago. 1,100 employees cut, 20% of headcount, on a quarter where the company posted record revenue and attributed the reduction directly to AI productivity gains. The Century Report has been tracking this arc for months, and the full record is on the ARCS tracker on the website. But what both cases share is that the cuts land in specific functional areas, such as written analysis, document review, slide preparation, model building, interdepartmental coordination, where current generation models are already deployed inside the company's own internal tooling. The throughput gain per remaining analyst is what the layoff math is built on. And this is what the displacement curve looks like when it stops being hypothetical. It shows up as a specific functional area inside a specific company, posting a specific number that does not bounce back next quarter. So let's be honest about the really hard part of this. 20,000 households in Southeast Michigan, Ohio, and Indiana are absorbing a structural change to what the word career means in their industry. The policy infrastructure that would smooth that transition does not exist yet at the scale that this curve will require. That cost is real, and it's difficult, and it is increasingly less concentrated as it gets to more and more fields. What sits alongside this, though, is the longer arc visible in that same evidence. The work being absorbed is the work the salaried class itself has spent decades describing as repetitive, low leverage, ripe for redesign. The slide deck that wrote itself, the procurement memo that wrote itself, the cross-team coordination email that consumed the morning, what the smaller number of engineers and analysts who remain at Ford and GM are arriving at in their actual workdays is the design judgment, vendor selection, and cross-team problem solving that the company has needed solved for years and could not staff against while the deliverable was the deck. The reorganization is painful. I don't want to gloss over that. But it is also, though, the leading edge of a redefinition of the rest of white-collar economy. And that rest of white-collar economy is about to follow. The word engineer is becoming something different. The word analyst is becoming something different. The companies that figure out what their salaried workforce should be doing with the hours that just opened up, instead of cutting against the old measurement and stopping there, are the ones that will look unrecognizable from the inside in 3 years. Now, that displacement is difficult, but what's on the other side of the absorption is real and amazing. So if you are salaried at a large company, the math being run on your function in Dearborn this year is the math that will be run on your function next year. The version of your job that survives is the version that does the work the slide deck was crowding out. All right, last story for today. Federal Judge Martinez-Olguin declined to grant final approval to Anthropic's $1.5 billion class action settlement with authors whose works were used to train Claude. The Century Report covered that settlement in March as it moved toward final approval, presented at the time as the largest AI copyright resolution to date and a template that other model developers were expected to follow. The pause changes what the template actually means, and there's more on this in today's edition if you're interested in the deeper dive. But here's the brief. The objector's central complaint is the arithmetic. Plaintiffs' counsel proposed taking roughly $320 million in legal fees from the fund. The remaining money, distributed across approximately 500,000 affected works, comes out to about $3,000 per book. The authors whose books trained one of the most commercially valuable AI systems in the world stand to receive a single payment 2 orders of magnitude smaller than the fee paid to the lawyers negotiating on their behalf. The judge wants the parties to explain why that allocation is fair before she signs off. So let's stay on the structure of what this exposes. The settlement architecture that AI training data disputes have been running on for 3 years now depended on the foundational legal question: whether training on copyrighted work without permission is fair use, being permanently externalized through out-of-court class payouts. Pay once, certify a class, paper over the question. Never let it reach a verdict. The economics worked here because the per-author number could stay small enough to make litigation more expensive than settling, and the fee for the plaintiff's counsel could stay large enough to broker the deal. Both numbers had to remain unexamined for the architecture to really hold. But the judge's pause puts both numbers on the same page of the docket. $320 million against $3,000 per book across 500,000 works that helped train Claude. The ratio between what was extracted and what is being returned is now legible in a single line of arithmetic in open court, with the parties required to defend it out loud. The architecture worked on opacity. Forcing the math into the record removes its central condition. What is being built on the other side of that removal is licensing as a precondition. 2 days before the judge's pause, you'll remember we covered this, a performer coalition led by George Clooney, Tom Hanks, and Meryl Streep launched the Human Consent Standard, machine-readable licensing terms a training pipeline reader honors before the corpus is even assembled. So this means that Martinez-Olguin asking what was extracted and the consent protocol publishing what would have to be honored next time both landed in the same news cycle. The route around the question is no longer cheap. The infrastructure for answering it upstream is now live. The next model developer thinking about training on copyrighted material without permission is making that decision into a different cost curve than the one that existed just last month. All right, closing out for today. All the evidence in one frame. A mathematician who spent 7 years on an open conjecture got a structural proof back in roughly the time it takes to watch a movie. A plant organelle that has never lived inside a mammalian cell in 1 billion years of evolution did photosynthesis inside a mouse eye for several days. A judge in California put the arithmetic of AI's quietest legal workaround on the public docket and asked the parties to defend it. And the salaried workforce at 3 legacy automakers is contracting by tens of thousands of seats, concentrated in the exact functions where current generation AI models are doing the work that the old org chart was paying for. The shape these stories share is what becomes visible when the capability and the response to it arrive in the same news cycle. The proof that Selke wrote up is legible. The boundary the cell paper crossed is legible. The fee-to-extraction ratio that Martinez-Olguin made the parties defend in open court is legible. The function category being absorbed at Ford and GM is legible. But none of those were legible a year ago. The instruments arriving this year are the instruments by which the next decade's institutional response is going to have to be designed. If you ever sat at a desk and built the slide deck that the model now writes itself, the version of your job that survives is the version that does what the deck writing was crowding out. And the companies furthest along that conversation are the ones inside which it is most worth working. If you have ever wondered what mathematics actually does over the next generation, the answer is that the bound that has shaped the discipline for centuries just moved. If you or someone you love is dealing with inherited blindness, then the kingdom boundary that ruled out a possible cure for the last billion years held less firmly this week than the textbook said. And if you have ever watched a class of legal architecture get assembled out of opacity, quiet settlements, small per-person payouts, fees that nobody had to defend, then the day the architecture stops being cheap to assemble is the day a different one becomes the easier path. The compounding is on both sides at once. The capability and the verification layer underneath it. The compression of years into hours and the institutional record that lets the next iteration be designed against what the last one revealed. What is becoming possible this year was not possible last year. The infrastructure being built to meet it is being built by the people closest to the consequences, in public, on a clock that compounds for everyone who picks the work up. We'll see you tomorrow.